So in China, there's a new machine, and it's so powerful that some of the headlines claimed it could literally fast forward the future. Yeah, a real-life time machine, but on this massive industrial scale. So what's the real story behind this incredible claim? Let's dig in.
Compressing space-time, that sounds like it's pulled straight from a sci-fi script, right? And well, that's pretty much what some of the headlines were shouting. But behind all that sensationalism is a piece of technology that, honestly, might be even more impressive than fiction.
You see, back in late 2025, the news just exploded about this new facility in China that could supposedly defy physics. Of course, it's not actually magic. The reality isn't about breaking the laws of the universe. It's about bending them to our will on a scale that we have never, ever seen before.
Okay, so to really get what's going on here, we've got to dive into the actual science behind it. And that brings us to this concept of hypergravity.
So at its very core, what we're talking about is a geotechnical centrifuge. Just try to picture a giant, powerful spinning arm. You place a small model, say of a huge dam, onto this arm, you spin it incredibly fast, and boom, you create what's called hypergravity. This intense force makes that little model experience the exact same stresses as the full-sized, real-world dam. It's like you're tricking the model into thinking it's absolutely massive.
To really put this power into perspective, let's talk about a unit called g-tons. Basically, it's the weight of the object multiplied by the g-force. Okay, so think about your washing machine when it hits that super fast spin cycle. That's putting out maybe 2 g-tons. This new centrifuge, the Chief 1900, it hits a staggering, world record 1900 g-tons. The forces at play here are they're immense.
And this, right here, is where the real magic happens. It's all about something called scaling laws. Just look at this table. You can take a 3-meter model of a massive 300-meter dam, then you spin it at 100 times the force of Earth's gravity, and the result? The stresses on that tiny model are absolutely identical to the real thing. It becomes a perfect physical copy, just shrunk down in size.
Okay, but this is the part that will really blow your mind. Because of those scaling laws, time itself gets compressed. A process, let's say water seeping slowly through rock, that takes a whole century in the real world, well, you can watch that entire process unfold in a lab in just 3.65 days. You are literally fast-forwarding geology. Now, this idea isn't brand new. It's actually been around since 1869. The first practical machines were built back in the 30s, and the modern era really kicked off in the 1970s. But what's happening now, in 2025, with this CHF facility? This is a true quantum leap. It takes this proven technology and pushes it into a whole different league.
So, what does a machine this powerful actually look like? Well, let's take a peek inside the giant.
This chart really tells the whole story, doesn't it? China now holds the top 2 spots for centrifuge power in the entire world. The CH 1900 and its slightly smaller sibling have now surpassed the longtime leader, which was in Vicksburg, USA. It really signals a new era for this kind of research. And as you can imagine, building something this powerful is a monumental engineering feat. For one, it's buried 15 meters underground just to keep it stable. It spins in a near vacuum to stop it from overheating from air friction. And get this, it took engineers with experience in building nuclear power plants to get it right. That's the level of precision we're talking about here.
Okay, so a massive, incredibly powerful machine. But why? What's the point? Well, it's all about solving some of our planet's biggest and most complex problems.
Let's take dam safety, for example. China has over 98,000 dams. A single failure could be an absolute catastrophe. With this machine, they can build a small model, spin it up, and simulate decades of wear and tear and even earthquake stress in just a matter of days. They can literally see how a dam might fail in the lab so they can prevent it from ever happening in the real world. And it goes way beyond just dams. We're talking about preventing landslides in dangerous regions, making sure high-speed rail tracks are stable for the long haul, figuring out how to build foundations for these giant offshore wind turbines, and even finding the best ways to safely store captured carbon deep underground. This machine is a tool for building a safer, more sustainable future. So, this all begs the question, where does this take us? What does this mean for the future of what's often called big science?
I think this quote from the chief scientist, Professor Chen Yunmin, just says it all. He says the goal is to create experimental environments that can cover everything from a millisecond to tens of thousands of years. Just think about that. They're not just testing what we already know, they are creating a physical space to discover things we can't even imagine yet. And you know, this centrifuge isn't just some one-off project. It's a key piece of China's whole big science strategy. It's about building these massive, world-leading scientific tools, like the famous Fast Radio Telescope, to go after the biggest scientific questions out there.
And what's really cool about this is it's not some secret closed-off lab. The whole facility is designed to be a global hub, totally open to researchers from all over the world. Whether your field is infrastructure, climate science, energy, or new materials, this is a tool built for everyone.
So, let's circle back to that original idea, a time machine. Well, no, it's not a time machine in the sci-fi sense. But in a very real way, it might be something even more powerful. It compresses the time it takes to learn, to discover, and to prevent disasters. It lets us peek 100 years into the future in just a few days. So the real question is, now that we have this incredible power, what new things are we going to discover?